So in this video, we are going to look at skip lists. So what is a skip list? Well, it has different pointer or link levels. It's still a linked list, but with different pointer or link levels. Certain connections are skipped between the nodes, and it reduces search time significantly compared to a standard linked list. So here we have an example of a skip list. Here you can see that this node, for example, points all the way to this node and skips all three of these nodes. And this node skips that one and points there. Well, you'd be right if you were thinking that there is some sort of organization in the skipping. It's not randomized. So now we look at a skip list with n number of nodes. A skip list with n number of nodes max level equals log base 2 of the number of nodes plus 1. Every second node points 2 positions ahead of itself. So it skips one, and every fourth node points 4 positions ahead, like that. And of course, every 8th node points 8 positions ahead, if you get to that number of levels, which in this case we do. So on any level k, you have 1 over 2 to the number of levels times the number of nodes on that level k. So n level k is equal to 1 over 2 to the k times n. And of course, this has got to do with the fact that these things are in powers of 2 apart. So, search in a skip list. Well, you start at the top level until you find an element greater than the element you're searching for. Then you go back one node on the same level, one level down, and compare on that level until a larger element is found. Then go to the next level. And you repeat this for all levels, going down one by one with the levels until the element is found or until all the nodes have been searched. So if I, for example, search for the value 8, then I'll first search across here. I didn't have space to draw the rest of it. But anyway, it will be way bigger than 8. So it'll be, for example, bigger than 17 somehow. So we know it's not going to be there. Therefore, we go back one node and we go down one level. Now we're on the second level and we're going to go forward. And we see 10. But 10 is bigger than 8. So therefore, we go back and we go one down. We go ahead one and we see 7 is less than 8, therefore we go ahead another one and we see, oh no, but 10 is still bigger than 8. So we go back one and we go down one and then we find 8. Okay, then we look at the insert. In the insert, we don't maintain the second, fourth, and 8th node pointers, these ones. And the reason for that is because when you insert elements, then it can get very confusing to maintain the pointers. For if you, for example, insert an element here, then to maintain this numbering, it gets very confusing to reassign the pointers to the various nodes, because you can insert many elements in one slot here and then it would take a lot of rearrangement. So therefore, we rather maintain the node count for each level instead. So on each level, there has to be the same number of nodes at any given point, but it doesn't matter what order they are in. And the level to insert at is randomly generated. So what does this mean? Well, we choose a random value between 1 and 15. And then we say, okay, well, if that number is less than 9, then we insert that element on level 1. If it's between 9 and 13, we go level 2. If it's between 13 and 15, we go level 3. And if it's equal to 15, we do the top level. So that is how the insert works. I will look at an algorithm now. And the same for the delete. I'll do the algorithm now. I'm just looking at the basic properties of each first. So for the delete, you search for the element and return if it's not found, of course. We find an array of predecessors for the insertion point. So we find the predecessor pointers, the pointers pointing to the node. So we find the pointers that are pointing to the node we want to delete, and then we of course have to reassign them to the next node after the one we want to delete in order to delete that node. We have to take care of our pointers properly. And once we've taken care of once we found the predecessors, those are the pointers pointing to the node we want to delete, then we delete the element and we reassign the pointers to this element. Okay,